Hello YouTube, my name is Matthew and I am going to be giving you a video on a chemical problem, a conceptual problem. It's no calculations, it's just conceptual. I actually looked on the ChemWiki that provided me with this problem, and there was two number 4s and I didn't know which one to pick, which one I was assigned to. Therefore I just chose the conceptual one, and it was the first one, so I thought that they were referring to that problem number 4, but there's another one that involves work and heat and changing volume with water being heated to steam at 100 degrees Celsius. I'm still able to do the other problem. I will put the link online just in case someone wants to try it, but we're going to do this one, this problem number 4. It's conceptual. So it says a microwave oven operates by providing enough energy to rotate water molecules, which produces heat. Can the change in internal energy of water heated in a microwave be described as a state function? Can the heat produced be described as a state function? And well, what is a state function? This would be the first question one may ask. So, according to ChemWiki, a state function is a property whose value does not depend on the path taken to reach that specific value. So, in other words, if I wanted to go from here to San Francisco, uh, I can take many ways to get to San Francisco, but what's more important is that I got there. What did it take to get there? Not necessarily what path did I take. So that's kind of an example of something that's not dependent on path. It's just, did I end up in San Francisco or not? And so it can be described in this and this is a change in time. So if this is calculus, if this is familiar to anyone, it's an integral sign here, and this is saying a period of time, so it's a change over time. So from t0 to t1, whatever time, from 0 seconds to 30 seconds, what have you. And this is the change in energy, so enthalpy right here. And so it can be expressed as from the final, which is what T1 was, minus the initial, where you started at. And then so it doesn't say. So this is a state function. It's independent of moles or the molecules it took to get from there to there. It's just where you started, where you stopped, and where you started at. So that's the change in enthalpy, which is a state function. So let's go back to our question to tie it together. So it says, can a change in internal energy of water heated in a microwave be described as a state function? And they told us what a microwave does. A microwave operates by providing enough energy. So we already have energy to rotate the water molecules. So tying this back into this energy here, when you take your water out of your microwave for you here to drink it, you don't care about the molecules. It's not much dependent. It's independent of path. It does not depend on the path. You just know that your water is hot. So this is a symbol for internal energy, is expressed in U. In scenarios, it's also expressed as E, but it's equal heat plus work. And work is not a state function. And it's because to move a pencil or move my finger from here to here, it took a certain amount of work. It depends on work is dependent on path, because I can move my finger up here. It took more work to get to this W. You see, or I could just go like this. It took a least amount of work, but it depends, because I can go all the way in a circle. And so that's why work is in a state function. And so is this? So the question is the change in internal energy of water heated in microwave be described as a state function? I believe yes, because like I said, you take your water out, it doesn't depend on the amount of moles or how much water. You just know it's heated. It started at this degrees and it ended at this degree. So what's that change in energy? That's a state function to heat the water molecules. So the answer is yes for the first part. And for the second part, it says, can heat produced by the can heat produced be described as a state function? And I believe no, and that's because I related it to something I've learned in general chemistry, which was the calorimeter problem. So the Q, and this is law of conservation of just energy and period. So if you gain something, you lose something. So that's that negative here. So if the energy went in, this positive, it went out negative. So this is just an example. It's not necessarily pertaining to this question, but heat is not considered um, a state function. And see, you can see here this M stands for mass, so it's dependent on the amount of mass you have plus this C constant and then your change in temperature. And so these here does not depend on path independent. This is just things to describe the internal energy and why we said yes. Sorry, I'm on a tangent, but the answer is no. Heat is not considered a state function in chemistry, and you can double check that online, or you can ask a professor. And so those are your answers to your conceptual problems, and I hope you've learned something about what microwaves do. And again, my name is Matthew, and I hope this has enlightened you in some way.